All right, so let's do a decay one. So this one's the pressure at sea level is 1,013 hectopascals. So that's 100 pascals. So we have this function y of t equals a e to the kt. This is a pressure at a given height. So E, our friend E, remember E we figured out before was from, and then as n goes into infinity. So you kind of see how this is related, right? So this was 1 plus 0.1, and kind of our, the way that this works is 1 plus some amount, but this amount gets smaller and smaller, and this, the period amount gets bigger and bigger. So it happens a lot that we get this letter E in these exponential problems. And this has a continuous function. So like as you go up in height, it's continuously, it changes just by microscopic amounts. Like if you go up by a microscopic amount, right? If you go up by a microscopic amount, the pressure increases by a microscopic amount. So that's how this works for turning it into an infinity. Okay, so anyway, save that for calculus. We don't need to do that now. So y to the t. So we want to find the pressure at the height in meters of Mount Everest, which is 8,048 meters. And we have this pressure constant that fits into this equation for K there. And it's just kind of a fudge factor that gets it to the right value. And it happens a lot in science, so don't worry about it too much. We'll just give it to you here. Okay, so this will be to the negative 1.28 times 10 to the negative 4 is K, and then times T, which was 48. All right. So I can find my Y value at that point, and I can just plug this all into the calculator actually. So 1,013 times E to the, let's see, I don't know if they have EXP. Yeah, EXP is the way you would write it. So this is negative 1.28 times 10 to the negative 4 times 8848. All that's in the parentheses. So this is kind of the exponential function, which takes care of it. So this is 326 hectopascals. Okay, so that's the way you do something with exponential decay. So this, you can see that it starts at 1,000 hectopascals, and then as you go higher and higher, it gets to actually about a third of the pressure. You have a third of the pressure at the top of Mount Everest that you do at sea level.